A galaxy so tiny it challenges everything we thought about the universe's infancy, and the list ends with a relic that predates most stars. Stay until number 1, where the answer will astonish you. Discovered in 2012 by a blind survey of neutral hydrogen, Leo P sits a modest 5.3 million light-years away, barely large enough to earn the title of a galaxy. Its stellar mass is only a few 100,000 suns, yet its oxygen abundance is among the lowest measured, indicating a chemical makeup similar to the universe shortly after the Big Bang. Despite its diminutive size, Leo P hosts a handful of newborn, massive stars that light up pockets of ionized gas, offering a rare glimpse of star formation in near-pristine conditions. Researchers believe its isolation has protected it from the metal-rich winds of larger neighbors, preserving its ancient character. Next, we travel to a galaxy whose chaotic shape hides a surprising past.
Surprisingly, DDO 68 looks like a distorted spiral, but its true story is that of a cosmic wreckage. Located roughly 12 million light-years from Earth, this dwarf irregular exhibits an oxygen content less than 3% of the Sun's, making it one of the most metal-poor systems known. Its twisted arms are the result of a recent merger with a smaller companion, a violent event that has stirred up massive gas flows while still preserving pockets of pristine material. Spectroscopic studies suggest that many of its stars formed less than 1 billion years ago, a timeline that mirrors the early epochs of galaxy assembly. Astronomers use DDO 68 as a natural laboratory to test how galaxies grow from chaotic beginnings. Up next is a galaxy that seems ordinary but holds a hidden record of primordial chemistry.
Hidden among the faint glow of the local group, UGCA 292 is a dwarf irregular barely 10 million light-years distant, yet its significance shines brightly. Its metallicity, measured at roughly 4% of solar, places it among the most chemically primitive galaxies accessible to detailed study. The galaxy's blue-white hue stems from a handful of massive, short-lived stars that are currently forging new heavy elements, a process captured in ultraviolet observations. Because UGCA 292 has undergone only limited enrichment, it serves as a living fossil of the conditions that prevailed when the first generations of stars ignited. Its modest gas reservoir also hints at a slow, steady pace of star formation, contrasting sharply with the frantic bursts seen in more massive systems. Coming up, a galaxy whose bright blue stars mask an ancient silence.
Bright patches of young, massive stars dominate Sextans A, a dwarf irregular perched about 4.3 million light-years away in the constellation Sextans. Despite its vivid appearance, the galaxy's overall metal content is merely 6% of the Sun's, a clear indicator of its primitive nature. Deep imaging reveals an intricate web of ionized gas shells, the remnants of supernova explosions that have both triggered and quenched subsequent star formation. Researchers have identified several ancient stellar populations, suggesting that Sextans A began forming stars over 10 billion years ago, then entered a prolonged lull before reigniting in the recent past. This dual-age structure offers a rare window into how small galaxies can experience multiple epochs of activity across cosmic time. After that, we'll look at a remote dwarf that still whispers the universe's first breaths.
Remote and barely perceptible, KKR 25 drifts on the fringes of the local group, some 7 million light-years from the Milky Way. Its faint, spheroidal shape contains a scant handful of stars, and spectroscopic analyses report a metallicity hovering around 5% of solar, marking it as a true relic of the early universe. Unlike many dwarfs that burst with star-forming regions, KKR 25 appears largely dormant, its gas reservoir exhausted long ago, leaving behind a quiet stellar population that likely formed over 12 billion years in the cosmos' infancy. The galaxy's isolation may have shielded it from the enriching influence of larger neighbors, preserving its ancient chemical fingerprint. Next, a faint galaxy that barely glows, yet tells a story of cosmic isolation.
Quietly orbiting the periphery of the local group, the Sagittarius Dwarf Irregular Galaxy, SagDIG, lies about 3.4 million light-years away, making it one of the most distant members of our galactic neighborhood. Its oxygen abundance measures roughly 7% of the Sun's, a clear sign of limited chemical enrichment since the Big Bang. The galaxy's modest star-forming regions are scattered across a diffuse cloud of neutral hydrogen, and deep imaging has uncovered a population of ancient red giants that hint at star formation dating back more than 10 billion years. This blend of old and young stars, coupled with its low metallicity, provides a living snapshot of how dwarf galaxies evolve in relative isolation. Following that, a tiny system that clings to the edge of the local group, revealing early star formation.
Ancient and enigmatic, LGS-3, also known as the Phoenix Dwarf, resides roughly 2.5 million light-years from Earth, straddling the line between dwarf spheroidal and irregular classifications. Its stellar content is dominated by an old, metal-poor population whose iron abundance is estimated at only 4% of solar, indicating formation during the universe's first few billion years. Sparse pockets of recent star formation, however, reveal that LGS-3 has managed to retain enough gas to spark occasional new stars, a rarity among such ancient systems. High-resolution imaging shows a central concentration of red giant branch stars surrounded by a faint halo of younger, bluer stars, suggesting a complex evolutionary history marked by periods of quiescence and activity. Soon we'll explore a dwarf where ancient stars dominate, hinting at a quiet birth.
Little Antlia Dwarf, perched at the edge of the local group about 4.3 million light-years away, bridges the gap between classic dwarf spheroidals and irregulars. Its metallicity sits near 6% of solar, and its color magnitude diagram reveals a dominant old population of red giants alongside a modest contingent of younger, blue stars formed within the past few 100 million years. This dual-age composition suggests that Antlia managed to accrete fresh, low metallicity gas after an initial burst of star formation, a process that may have been triggered by a close encounter with the nearby galaxy NGC 3109. The presence of both ancient and relatively recent stars provides valuable insight into how small galaxies can rejuvenate themselves over cosmic time. Now, a galaxy that holds the title of the most celebrated primitive system, but the ultimate champion lies beyond.
Famed for its striking blue hue, IZW-18 resides roughly 59 million light-years away in the constellation Canes Venatici and has long captivated astronomers as the most metal-poor galaxy observable with modern telescopes. Its oxygen abundance is measured at just about 2% of the Sun's, a composition that mirrors the primordial gas from which the first stars emerged. Despite its extreme youth-like chemistry, the galaxy hosts several star-forming knots that have ignited within the past few million years, creating massive, hot stars that flood the surrounding nebula with intense ultraviolet radiation. Detailed studies suggest that IZW May 18 have experienced a prolonged period of dormancy before this recent burst, making it a living laboratory for studying galaxy evolution in near-pristine conditions. Finally, we approach the most celebrated primitive galaxy, but the ultimate champion lies beyond. Reflecting on these 10 primitive galaxies reminds us how much the universe still hides in its oldest corners, offering clues about the first stars, the birth of heavy elements, and the forces that shape today's cosmos. If you enjoyed this deep time journey, hit subscribe so you won't miss the next mind-blowing list we drop each week. Which galaxy surprised you the most? Was it the nearby dwarf or the distant GNZ11? Let me know in the comments, and please give this video a like if it sparked your curiosity. Thanks for watching.